I would love to hear from Heli. Hi, Heli.
Hello.
Hello. So I remember that. Here we go. So what is the I don't know if you want to talk a little bit about because you are the CIO of Miracle from Miracle Finland that you have founded to. You have been doing a lot of things, not only for consultancy and all the projects that you are doing, but you also write books, presenting in conference, get a master in the middle of all of that. So if you want to let us know in the I don't know, maybe from 2 to 3 in the morning, what are the things that you are playing around, because I don't know where do you have time to do all the stuff. So what are the things that you really like it about Oracle Technologies this year?
So I just realized when you asked Maria how long she'd been working on Oracle, and I said, wow, I have been actually working 30 years with Oracle products this year. Wow. So yeah, I feel old, but I love Oracle technology.
We all know that you started in kindergarten.
Yeah,
do not worry.
I did. Yeah, kindergarten was a good place for Oracle products. So I have been working with fantastic products this year, and I did have a problem to decide which one to choose to talk about. There's a lot of interesting things about Analytics Cloud, there's AI services, so many cool things. But I decided I will talk about AutoML because that's something that I think if you don't know yet, you should know. So AutoML, you can find it from here, from the Oracle Machine Learning. And let's see if I can change the slide somehow like this. So in AutoML, they are called experiments. So you are building experiments when you start the machine learning process. So you create one by pressing create here on the screen. So by pressing that, you can start creating an experiment. The experiment starts by defining a name for your experiment and then defining the data source for it. So the data source is either a table or a view. After you choose that, you decide what is the thing you are going to predict. What are you trying to predict? What is the column that you are trying to define? Based on what you choose here, if it's a varchar type, what you are going to do is a classification problem. You have a classification problem. But if you choose something that is of type number, you're actually doing a regression kind of machine learning problem here. You can also define ID for your data, but that's not mandatory. So what did I talk about? Classification. So if you chose the varchar and ended up doing a classification, classification means that you are putting things into categories. So you are having cats and dogs, or you're going to have white, red, and let's say green. So you are putting things into classes. That's classification about. So depending of the problem you are solving, you have different kind of algorithms. The algorithms depend on your technology and your Oracle version. So here for me, I have classification problem with this kind of algorithms available. I can either take all of them or I can just choose some of them. I can also define additional settings for my experiment. I can define how many top models will be shown to me after it has built the models, how many of those will be shown to me. What's the maximum duration of this run? So when it's building the model, how long can it take, the maximum? And what is the connection level I'm going to take to my database? Is it going to be low, medium, or high? So how much resources do I have for my process? And then what is the main metric that I'm going to use to define which of the models is the best? Well, if instead I chose something called regression, what I'm going to do is I'm going to predict a number. Temperature tomorrow, a stock price on Friday, something like that, so a number. And therefore, the algorithms I have available are a little bit different. So here I have some algorithms available. Otherwise, all the additional settings are the same, except the metric. Because in classification, I'm trying to figure out what is the value, while in regression, I'm trying to get as close to the prediction as possible. So the metrics are a little bit different. So this is the part of mathematics that you don't have to really understand, but it's math. So trying to find the best model is the target in each of these. And the metric defined tells which one is the best. I can also define the features. So for us database people, features actually means columns. So I can see the columns of my data set. I can see all kind of detailed information about them, like the minimum value, maximum value, mean, the standard deviation, distinct values, how many nulls, and so much more about the data. Well, actually, in this point, I might realize that I have wrong data types to my data, and I might go back and fix my data before actually giving it to the experiment. But now I have everything correct, and I'm going to keep all these features when I'm building the model. If I think one of these is not really, has nothing to do with my prediction, I can just deselect it from the data set. And then I just start my experiment. I can do the fast, or I can do the better accuracy version of the process. After it's run, it will show me all the algorithms I just chose and a model that it built using the data and using this particular algorithm. And it also shows me the metric that I chose in the beginning. And from here, I can see what is the best model to be used in production if I feel this is good enough. I can also have other additional metrics. If I'm not sure, like you saw here, I have two models that are equally good. So if I want to take more metrics, I can just add from here, and I will see them for each of my models, just like that. And I can decide which of the models is the best. I can also rename the model, because why would I go to production with something called SVMG _ whatever? So I can rename it with a proper name before going to production. I can also go and check this particular model. What were those features that impacted the most for the prediction? So what columns are the most important ones for predicting whatever I was predicting? I can also see the confusion matrix. I don't go to details on this one, but this might be your best friend when you are choosing which of these algorithms actually is the best. Then I can also deploy the model. So if I deploy the model, I can use the REST and just call my models from maybe Apex or somewhere outside the database. When I deploy it, I just define the parameters needed for deploying. And that's it. And if I define here shared, this model is actually usable also for other users, not just me. If I don't do that, it's only for me. If I go here in the main menu and select models, I can see these models under deployment. So those models that I have deployed is shown here under deployments. So these are the ones that you can go and call from anywhere if you have permission to do that. I can also create notebooks. So you have probably heard about notebooks. So this is something that is also available here in Oracle Machine Learning. So if I just created a fabulous model here, I can just select the model and say create notebook. And what it does for me, it actually creates a notebook, which you can find from menu under notebooks like this. So the whole process I just did using AutoML is documented as a notebook, which I can just open and start editing. And actually, this is done in Python. So this is a good way to learn Python too. So building a model, getting a notebook, and starting to read how it looks like in a notebook. And do you know what? It's 7 minutes, and I have exactly 7 minutes to talk about. Thanks.
Thank you so much, Heli. Thank you so much.